So the general rule for negative exponents is usually written like this. A to the power of negative m is equal to 1 over a to the power of m.
What? Oh. That doesn't make any sense.
If you have a power where the exponent is negative, what this means is you can change that exponent to a positive number by flipping the base over. This is written as an a, but remember that's always over 1, right? So really we're just flipping it over. So if we look at this one, 2 to the power of negative 3, I can make that a positive 3 by taking the 2 and flipping it. It's a 2 over 1 now. I'm going to change it into a 1 over 2, and then I'm going to put a positive exponent on it. So 2 to the power of negative 3 is the same as 1 over 2 to the power of 3, which is actually 1 over 8 if we do 2 to the power, 2 times 2 times 2. And like I said, this is how the general rule is usually written, and that's how you'll see it in your textbook. Sometimes, though, I like to write it like this. If you have a fraction a over b to a negative exponent m, that's the same as b over a to the power of positive m. So it's the same rule, but it's written a little differently. If you flip this over, the exponent switches to positive. So it's just another way to look at it. But we're going to look at some examples of actually using that law that'll help you to kind of make sense of it. So let's look at these ones from the first page there. If I do 3 to the power of negative 5, I want to change the 5 to a positive, but what do I have to do to the 3 to do that?
Flip it.
Flip it, so make it a 1 over 3. 1 over 3 to the power of 5. And then if I actually evaluate that, 3 to the power of 5 is 243, so we could call that 1 over 243. Let's look at this one, negative 12 to the power of negative 4. We're going to change that to 1 over negative 12 to the power of positive 4. So change it to 1 over, make the exponent positive. So then I'm going to do negative 12 to the power of 4, and this becomes 1 over 20,736. If you're doing this on your calculator, negative 12 to the power of 4, anytime that the base is negative, you need to put it inside brackets on its own. So go bracket, negative 12, bracket, and then to the power of 4. What about this one, 1 over 7 to the power of negative 2? Flip it, so it becomes 7 over 1, or just 7 to the power of positive 2, which is 49. And the last one here, 2 over 3 to the power of negative 5, flip it. So it's 3 over 2 to the power of positive 5. And then you can do 3 to the power of 5 over 2 to the power of 5. That's from those rules that we looked at before. And then 3 to the power of 5, we already said, was 243. And 2 to the power of 5, is that 32? Yeah. So this becomes 243 over 32. Can that reduce? I don't think so. No, can't. So in general, we don't want negative exponents in the answer. But this one is pretty straightforward. It's all of this stuff to the power of -1. So what I need to do is flip it. This becomes c cubed over a squared b, and it's to the power of 1. So it's actually just c cubed over a squared b. So you don't even need that power of 1. But I put it there just so you can see what happened. When this flipped, the negative turned to positive. And then that's just the final answer there. That one wasn't too bad. Let's see what else we have. This actually looks just like one that you could have had yesterday, but the difference is what we're going to do at the very end. So, let's start doing the dividing. 10 divided by 5? 2. A to the power of 7 divided by a to the power of 6. A to the power of 1, right? So just a. 7 subtract 6 is 1. And then we have the b's. B to the power of 9 divided by b to the power of 10. -1. B to the power of -1. And then c to the power of 6 divided by c to the power of 8. C to the power of -2. And yesterday this answer would have been fine, but now today this answer is not fine. Because we don't want to leave negative exponents in our final answer. We did one like that, you did one like that yesterday, and I said that's okay to leave it like that. But now we know that we can do something with the negative exponents. And remember, we flip it, right? So that b to the power of -1 becomes a 1 over b. But really, here's what it's going to look like. The 2 and the a are not going to flip. They're going to stay like that. So they become the numerator. The b and the c are going to flip, so they go to the bottom. So instead of doing 2a times 1 over b to the 1 times 1 over c to the power of 2, I'm just going to take the ones that are negative, put them in the denominator, and make the exponents positive. So it's just kind of skipping a step in there, but it really simplifies it. If it has a negative exponent, move it to the denominator and make it a positive exponent. I have just one more for us to do. This one. Let's simplify inside the brackets first, I guess. 4 over 8 reduces to a 1 over 2. And then if I do a squared divided by a, that's just an a on the top. B cubed divided by b to the power of 5 is b to the power of -2. And then this is all to the power of -2. So now we'll take the -2 and we'll put it on each base. So a to the power of -2, b to the power of, but you're multiplying, right? Yeah, +4. And then 2 to the power of -2. The b to the power of 4 is going to stay where it is because it's a positive exponent. The other two, the a to the -2 has to switch down to the bottom. The 2 to the -2 has to switch up to the top.
Why are they switching? Why don't you just do?
Why are they switching? Because they're negative exponents. So the 2 to the power of -2 goes to the top. It becomes 2 to the power of +2, which is 4. The b stays where it is. And the a to the -2 goes to the bottom as an a squared. And that's what you end up with as your answer.